Okay, so now we're going to take a look at how to improve, or how to blend stations with a background field, like a satellite data set. In this case, we're going to use chirps, and we're going to blend the stations available for a given period of time with the chirps for that period of time. So the first thing, let's take a look at the format of the station file. So this is the station file, this is the country, station name, the source, and the main thing is that the file has to be in columns for all the different, in this case, are months. It has to have a year, an ID, a latitude and longitude. Those are the main columns that we need. So it doesn't matter mm, how many columns or anything extra, but those columns have to be there. And in the case of the stations, it only has to have a single no data value. So in this case, it's minus 9999. Sometimes we could use different numbers to represent no data value, but in the case of the stations, it has to be a single number. So then these are the stations. Let's make sure that is closed before we start working in blending with the satellite data. And another thing important is that the program does not take symbols. Like if we have in this in the name, sometimes we have an apostrophe or anything like that. It doesn't take those things, so it will give you an error. So let's close this and let's open. Let's click right here in the basics, and the default is for blend raster or grids with the stations. That's what we want to do. So we want to go next, and here we can do any time intervals. We could do pentads, decads, monthly, daily. This one right here, month to decades, is when we have monthly stations with decadal satellite data. So we could blend those two, because the program breaks down the stations into decades and then blends them with the satellite data. So in this case, we're going to use months, and we want to start from the month 1 of 1981 to the month 7, 2013. Then that's all we need here. So go next. Then step 3 opens up. In step 3, we have 3 sections. One, this section right here is for the information for the grids. This is section 2, that is the information for the stations, and this section out here is the information for the outputs. So let's start filling in the information for the grids. So the no data value for the grids is 4 minus 9999. So in here we could have a range of values for no data. We could sometimes we use different values for no data to represent no data. So here we could have a range of values. In the station we must have one. Folder containing the grids. If we're gonna use the default GeoCLIM dataset, then we're gonna click on that one. If we have it in a different folder, so we're gonna use that folder. So this folder is gonna be using, in this case, we're gonna use the chirps global monthly. So the format, so as soon as we click in the GeoCLIM, so it reads what's the format. So it's chirps. The date format is 4-digit years and 2-digit month. Here we could have other different formats for the date, and the suffix is .bil. So this is these are mm, the different directories that I have in my data archive, in my data directory. So I could select any of these um, directories also, but in this case we're going to use the global. So this is for the stations. Then we're going to bring the station table that we just saw at the beginning of the video. So the stations have a value of -9999. Then we're going to browse to where the stations are. So we call it EAC precipitation. So as soon as it reads the station, the station table, it selects the header is number 1, is row number 1. The first data row is number 2, is comma delimited, so perfect. Then it takes a little while to read the station, and then it populates some of the fields. So we just want to make sure that if the fields are correct. So it says that the column ID is number 2, but no, the column ID is this one. The latitude is correct, and the longitude is number 4. Number of header lines is only 1. The column with the year, that is correct, it's number 8. Then the first column with data is this one, and the last column is that one. So now we have completed all the information for the grids, all the information for the stations. So now we are going to complete the output. So in the output, we want to have an output diagnostic statistics. This is a file that has all the information on the statistics between the point data values with the values for the same points where the stations are, the values from the satellite, so that we could compare what was the value of the station, what was the value of the satellite at that point, and then the value for the same points at for the final product, so that we could compare all the different values to see how good our results are. Then we want to select a folder where we want to place our final products. So let's go to see. By this time you have very well memorized this path. So we go to GeoCLIM, program settings, data, climate, and then here I created a directory called EAC rain, and that's where I want to place my final product. So we're gonna give it a prefix. So just to make it different, I'm gonna call it EAC, and I want to give it 4-digit year, 2-digit month, and this one is that BIL. The statistics, we're gonna put it in the same place. GeoCLIM programs data. As you see, we go to this directory very often. So we're gonna call it EAC stats. Perfect. So we have completed our 3 sections. There is one place here that we want to click on this one, and you see this whole other section opens up. This section right here is related, all this information is related to the interpolation. This is the interpolation that we use in this method in this process is a modified inverse distance weighting process or interpolation. So it is modified because we give it a limit of how far the the weight of the point is has an effect. So we give an effective distance for each point, depending. This is based on the station and how far the station, how much effect that station has. So we give it a distance. So that's going to be a radius around the station. So we leave it in 100 because it's Africa. In Central America, it could be 30 or 50 kilometers. And so there are many things that we don't move from here. This all this information, if unless you know exactly why you want to move it, then you can, or you can try it to make to see what difference it makes. So now we're going to define the map limits of where we're going to work. So in this case, I'm going to a GeoCLIM region, and we have EAC. So we're going to use the EAC region boundaries. So that way um, it's giving us the limits for our process. Here is if we want to define a new pixel size, or if the stations are in different tables. So that's not our case. So we are done. So let's click finish. Then all that form, what it does, it creates this code. And this is where this is what we're gonna do. We're gonna run this code. So it's very important to save this file. I'm going to save it in the GeoCLIM program settings, data, climate. I'm gonna put it in the same place. Or something that I do, and this is my own way of working. So we can in here, I'm going to create a directory called code. So what I do is I go there and I save this code as, so that way whenever I need to modify this or rerun this rainfall, I don't have to go through the whole process again. I just can unchange whatever parameter I need to change. So here he explains all the information that we fill in the form. He has it here in formatted as code. So now that we saved it, we're gonna run it. So it starts running. The program gives a window that is telling us what's going on in the process. For example, when it started, it gave us information about an error, that there was no station data for the first month of 2013 and so on. On 2013, we didn't have any station data, so the window is telling us as it keeps going. This is information on the blending of the stations and the chirps for the other years. So there was no problem for up to 2012. So at the end, it gives a series of graphs of scatter plots and the CSV file that we created in the form. You remember here in the output diagnostic statistics that we checked, and we gave it a name. So it produced that file that is this one right here to the right. So this file contains all the records that of the process, the for the station value. So it takes the station value, it takes for the same point where there are stations, it takes the value for the different products. So what I do is I put this file, I open it up in Excel to take a look at the different columns and different products, and to produce my own graphs. So what I do is I open it up in Excel. This column is telling us the ID of the station. This is the month and year that we just run, longitude, latitude. This is the station value. This is the original grid value, which is in this case was chirps. So this is the value of the chirps for that point where this station is. Then the IRE is the improved rainfall estimate. So this is the final product. This is when we blended the stations and in this case the chirps. This is the value of that pixel where the station falls. Then the cross-validated IRE is when we run the process without this station right here. So what is the value at that pixel where the station falls when the station is not included? So every time we run the process with the station, and then we run the process without the station, and we take the value. This is the value with the station, and this is the value without the station. So this is a very important column for us because it's telling us how are we estimating the rainfall at that pixel when there is no station. Then this is the interpolated stations without any chirps or anything. This is just using a regular IDW interpolation. This is the cross validation for the IDW interpolation is the same thing. This is where when the station is not included. So just to make the graphs consistent, I put the station value here because then when I plot I make any plots, then this is the Y value, which is the observed. That's what we want. So in this case, these are the station values, and these are in this case we're plotting the stations and the cross-validated IRE. So the stations plot on the Y, and the other column plots on the X. So then we can see how the IRE takes most of that pixel takes pretty close to the value of the station that falls in it, and so forth. This is the original chirps value at those stations. So this is so you can play with all the different columns, and at the end of the file, at the end of the table, we have statistics for the comparison of the different columns. So here is the interpolated station value against the original gridded value. So the R square, it gives all the different statistics that you can take a look, and this is the final product that comes out of the basics process. Let's take a look at the directory, at the output directory that we set up when we fill out the form, and see what really was produced in that directory. So we have to go to our famous path where we get to GeoCLIM, program settings, data, climate, and the EAC underscore rain. That's the directory that we set up at the beginning. So let's take a look at what is created in here. So we see graphs. This is comparison of the different columns that we saw before, but this is for that given month that we are that we are opening the graph. So there is an image that is, this is a very important image to see, and these are the different squares, the different those are the different points, the different stations that went into the process for that given month. The number of stations could change from month to month, and then in 1982 06, that was the sixth month of 1982. There were so many stations. If we look, and let's take a look at a later date, let's take at 2012, you see that there were just a few stations available. So the number of stations could change. So these are the different products that you see in the directory, in the output directory. So sometimes this information is useful, so it's good for you to know what it is.